Okay, this is review for the Algebra 1 test on Tuesday, August 25th. So here's some vocabulary for the test. First up is absolute value. Absolute value is the distance from 0 on the number line. Here we have 0, it's 1, 2, -1, -2. And 1 is 1 distance away from 0, and 2 is 2 distances away from 0. The same for -1, which is also 1 distance away from 0. -2, which is 2 distances away from 0. A way that you can think at absolute value is just, if you have a number, any number, be that number, but you take away any minus sign in front of it. So now we move on to definition for a perfect square. A perfect square is any number that can be taken through a square root. It's a whole number, can be taken through a square root. So 9 is a perfect square because it gives us the whole number 3. It's not something like 11 that does not have a real perfect square. Square root, we did it up there. It's basically the opposite of if you take a number, let's say in this case k, you square it. So if you take k, you square it, you get k squared. Then if you take whatever number k squared was and put it through the square root, you should get k. An example of that would be if you have 9, you square it to get 81. The square root would be 81. So over here I have written our circles of types of numbers. Now, to encompass it all is the real numbers. For all of this, it's every single one of these categories. The natural numbers are numbers. They are all whole numbers that do not include 0. 1, 2, 3, ... Whole numbers are all positive numbers that include 0. 0, 1, 2, 3, ... An integer is any positive or negative whole number. So now we move on to -3, -2, -1, 0, 1, 2, 3. They extend both directions. A rational number is a number that can be expressed as a over b, where a and b are integers. So some examples of that would be 8 divided by 2, which would give us 4, and even 1/3, since it can be written as a over b or a fraction, give us 0.3 repeating. Now over here, in irrational numbers, these are numbers that cannot be expressed as a over b. They are things like the square root of 2. A neat thing to know is that any square root of any prime number, be it 2, 3, 5, 7, 11, they will always be irrational. And so all of these will fit into the category of a real number. Now, the only types of numbers that do not fit into the real numbers are a good friend, the imaginary numbers. It is as an I. Well, you would write it as an I, and it could be any number, say 3i. That would be an imaginary number, and they are a separate bubble from the real numbers. So, these are the rest of the vocabulary. We can start off with distributive property, which states that A times B plus C is equal to A times B plus A times C. What this basically means is that you can take a number outside of the parentheses and distribute it to all the numbers inside the parentheses. So if we had 5 times 7 plus 2k, we can take the 5 times the 7, and we can get 35. Then the 5 times the 2k, which is 10k. Associative property states that A plus B plus C is the same thing as A plus B plus C, or A times BC is equal to AB times C. What this basically means is that you can do addition and multiplication in any order you want. So we wouldn't even have to do ABC. We could do AC times B. A way that this is helpful is if you have 5 plus 6k plus 10, we can add these together without breaking that rule. It's the same thing as 15 plus 6k. The commutative property means sort of what I said up there is multiplication and addition can be done in any order. So A plus B is the same as B plus A. Additive identity. At this point, it sounds like mathematicians are just trying to sound smarter than anyone else. This is basically any number, k can represent any number, plus 0 will be that number. Anything you try, even our lovely friend I, which represents the imaginary number plus 0, it's still going to be I, no matter how hard you try. Multiplicative inverse. And this one means any number times the reciprocal of that number will equal 1. It's for every number. Even if you had 2/3, if you multiplied it by the reciprocal 3, 2, that will equal 1. Then there is the multiplication property of 0. It's not that hard. It's just any number, our lovely friend k, times 0 will equal 0.